All right, so let's continue. In this example, we're given the value of sine of x and of cosine of y. And then we are told that both x and y are in quadrant 4. So that means the angles are in quadrant 4. And we're asked to find sine of x minus y and cotangent of x plus y. So let's see. Sine of x is negative 4/5. I know that sine in terms of opposite, hypotenuse, and adjacent, I know that sine is what? Sine is opposite over hypotenuse. Okay, so we are told that these angles x and y are in quadrant 4. I know that hypotenuse is always positive, so hypotenuse is 5 and negative 4 for x. And then cosine of y equals adjacent over hypotenuse. And that gives me 5/13. Okay, so this means for x, an angle in quadrant 4 will be this. And since the hypotenuse is 5, this means this value is 5. And then the opposite to angle x is negative 4. Okay, so we can use the Pythagorean theorem to find that adjacent is 3. So you do negative 4 squared plus adjacent squared equals 5 squared. And if you solve, you get that it's positive 3. And then similarly for y, we were told that y is an angle in quadrant 4. So it's going to be again, y is here. And it says that opposite is, adjacent is 5. So that means that the side adjacent to the angle y is 5. And the hypotenuse is 13. Again, by using Pythagorean theorem, you should get that the y value is negative 12. So how do we do that? Well, I know that adjacent squared is 5 squared plus opposite squared equals hypotenuse squared. So this will give you that opposite squared equals 13 squared is 169 minus 5 squared, it's 25. So opposite will be equal plus or minus square root of 144. But since opposite is a y value and the y is negative in quadrant 4, you pick the negative. So that's why opposite is negative 12. Okay, so now we are asked to find sine of x minus y. So notice I don't know what x is and I don't know what y is, but I know they're quadrants in angle. They're angles in quadrant 4. So for this one, basically I need to remember what the formula is. Instead of u and v now, I call them x and y. No big deal, right? So let's go back and see what the formula is for sine of u minus sine of v. So sine of u minus sine of v is this one. So it's going to be sine of the first times cosine of the second minus cosine of the first times sine of the second. So going back in here and following the formula, this is sine of the first, so sine of x, times cosine of the second, minus cosine of the first, which is cosine of x, times sine of the second. Okay, so now, what is sine of x? Well, sine of x was given to us in the problem that it was negative 4/5. What is cosine of y? Cosine of y was also given to us to be 5/13. And then minus cosine of x. Cosine of x was not given to us, but from our picture right here, we can get that cosine of x is adjacent, which is 3, over hypotenuse, which is 5. And then sine of y, again, we were not given what sine of y was, but by looking at our triangle, we know that sine of y is opposite, which is negative 12, over hypotenuse, which is 13. So if we calculate this, this should be negative 20 over 5 times 13, 65. I have a negative times another negative, so this is going to turn to positive 36 over 65. And when I combine these two together, I get positive 16 over 65. So this is the answer. Sine of x minus y equals this. So even though we didn't know exactly what x and y was, by using the formula for sine of u minus v, we get the actual value for sine of x minus y. Now similarly, now we got to do cotangent of x plus y. So we got to look at the formula. What's cotangent? Cotangent, well, it doesn't look like they give us a formula in here, but we know that cotangent is the reciprocal of tangent. So cotangent of x plus y, or u plus v, is going to be 1 over tangent of x plus y. So cotangent of x plus y is going to be this fraction, but the reciprocal of it. So it's going to be 1 minus tangent of x times tangent of y over tangent of x plus tangent of y.